All right, guys, we are going to look at section 8.3 today. It is all about limiting factors. Let me scroll up here to find it. More math. This chapter is heavy in math. All right, so back earlier, I talked about s'mores pops, and usually we get to make them in class, but we didn't get to this year. So normally this is what if you were to look it up on the internet, it says that you need 24 marshmallows, 1 chocolate bar, and 4 graham crackers, and if you have all of that, you will make 24 normal s'mores pops. So if I go into the cabinet and find a bag with 10 marshmallows, 1 chocolate bar, and a box of graham crackers, what limits how many s'mores pops I can make? Like, which one am I going to run out of first is what they're asking. So it's going to be my marshmallows, right? I have 10 marshmallows and normally I need 24. My chocolate bark is okay, and I have a box of graham crackers, so that's fine. But my marshmallows are going to limit how many I can make, right? So that is what we're talking about here. Now it says the second problem down here, right here. If I have 48 marshmallows, 1 chocolate bar, and 8 graham crackers, how many s'mores pops can I make? And then what limits me? So if I'm looking at this, I can see that this has doubled. I can see that this is the same. And I see that this has also doubled. Now I used these numbers for a reason. I used numbers that were nice and easy where we could see that they had doubled exactly. But my chocolate bark stayed the same. So technically with 48 marshmallows and 8 graham crackers, I would be able to make double the batch. But I just have that 1 chocolate bark that stays the same. So I can only make 24 s'mores pops. If this doubled, this would make 48. This one would make 48. But since this stayed the same, this will only make 24. So I can make 24 s'mores pops because after that, on my 25th, I run out of chocolate. Okay, so my chocolate bark limits how many I can make. So that one was a little bit easier because it was numbers that we tend to comprehend a little bit better, where we see just a double or a triple, or if we cut something in half, we tend to be able to, we can do that. But then when you add chemistry plus weird numbers on top of that, that can make this a little bit more difficult. So that's when we start doing the conversions with the parentheses. All right, so let's look at this next one. I'm going to use the parentheses for this because some of you might be able to do this in your head, but others might be like, I don't know. So using the recipe for s'mores pops, how many s'mores pops can I make if I have 1/3 of a chocolate bark? So 1/3 is going to be approximately 0.3. So what I would do in any type of chemistry problem or anything, I'm going to write down what they give me. So I'm going to write down 0.3. I'm going to put CB for chocolate bark. Now in chemistry, you see me, I'm always write down what they give me and then I do these parentheses. Now whatever is out here outside is going to go on bottom, chocolate bark. Now I want to know how many s'mores pops I can make. So I'm going to put SP here for s'mores pops. Now it says using the recipe. If I go back to this recipe up here, it says that I had 1 chocolate bark. 1 chocolate bark made 24 s'mores pops. Right? So then it's just like any other problem. I can cross out the chocolate bark and it leaves me with how many s'mores pops I would make. Now 0.3 times 24 is 7.2 s'mores pops, or 7 I guess, because you wouldn't make 0.2 s'mores pops. But anyways, that's your answer. So we can do this with recipes for food. But then we're also going to do this for chemistry because as much as, I don't know, chemistry teachers probably hate to say it, it is a lot like doing like cooking where you're, oh, I only have so much of this. Let's do a half batch of cookies because I don't have enough. It is similar to that in that way. All right, what is a limiting reactant? A limiting reactant is something that stops a reaction. Right, it's the first thing you run out of. So if you're cooking at home, like what is the first thing you run out of and then you're like, oh, I'm done, I can't cook anymore? So using the recipe for s'mores pop, circle the reactant side. So guys, the reactant side is always going to be on the left of the arrow. So basically, if I have these three ingredients that react or I put together, then I'm going to make or produce my product, which would be 24. So now we're going to throw chemistry in with this. All right, so instead of saying marshmallows, chocolate bark, graham crackers, we're going to, instead of marshmallows, it's hydrogen. Instead of chocolate bark, it's chlorine. And when I add these two things together, I get hydrochloric acid, and I have 2 moles of it. All right, it's just this becomes a little bit more difficult because we see chemistry words and terms, and we see moles. So let's look at how to do this. It says step 1. Step 1 when you're doing limiting reactants is always going to be find the moles of product made by each of these. All right, so you're going to find moles of product made by each reactant. It is always, this whole section is going to be all about how much product are you making. Okay, we're trying to figure out what limits us in making the product. So it's always how much of the product are we making. So in this case, I'm going to do it in a different color here. I have 4 moles of hydrogen. I'm going to put moles of hydrogen down here. Now all I need to do is figure out how much product. So I'm going to put moles of HCl. Now I could go on to figure out how many grams, right? I can go from moles to grams, but it doesn't tell me to. It just wants to know how much would I make. So I'm just going to stop here. When I have a mole to mole, I am going to use this equation right here. And for every 1 mole of hydrogen, there are 2 moles of my product. So 4 times 2, 8 moles of HCl. Right? So if I have 4 moles of hydrogen, I'm going to make 8 moles of my product. Now, they also say I have 2 moles of chlorine. So I'm going to put that right here. I'm still trying to figure out how much product is that going to make me? Is it going to limit how much product I can make? So I'm going to have moles of chlorine on the bottom. Once again, my product is always what I'm looking for, so I'm going to put that on top. And this is 2 and 1 if you're using that equation. So 2 times 2 is 4 moles of my product. So my HCl is going to limit how much I can make, because I will make 4 moles of HCl and then I'll run out of chlorine and I'll have leftover hydrogen. So chlorine is going to limit how much I can make. All right. Now, just kind of a side note here, I'm going to go ahead and erase this. So if you are still writing and you need to pause it, that's fine, but I'm going to erase this so I can write something down. All right, so a big thing here is I always give you these guides to help you. And with these guides, we've talked a little bit about this. Grams of 1 go to moles of 1. And I switch over to moles of whatever I'm looking for. That number 2 is what I'm looking for. Now in this section, it's always going to be product. And then if I want a weight, I can do this. So right now, what I did with this one, this first one we saw, is I went from moles of my reactant to moles of my product. It was just a 1-step problem, switching over. Now if we look at this learning check, it says which one is the limiting reactant? And then it says calculate the mass of water produced when. Now they are starting us at grams this time. So I'm going to have to go from here to here, and then I'm going to go from grams of hydrogen to moles of hydrogen, and moles of hydrogen to moles of my reactant. And there should be an arrow here. I don't know why it's not there. All right, I have to do this to 2 of them. So that is kind of the downfall of section 3. It's almost like there's 2 problems in one. So let me look at this. I have 8 grams of H2. Now this first step, grams to moles. We'll put grams of hydrogen. Now look, I am in grams of 1 to moles of my same one. So it's going to be moles of the same one, number 1, on top. Now H2, hydrogen weighs 1, but there are 2 of them, so it's going to be 2 in every 1 mole. Now I'm going to switch over from moles to moles of number 2 of my product. So I'm going to put moles of hydrogen down bottom to cancel out. My product is water, H2O. Now when I do a mole to mole, I'm going to use the equation right here. So if I'm looking, I see that for every 2 moles of hydrogen, I have 2 moles of water. So this one actually just ends up reducing. All right, so this one would be 4. You would make 4 moles of water. Now let's do the second one, because remember, I'm trying to figure out, is hydrogen limiting me or is it the oxygen? So if I have 24 grams of oxygen, I'm starting this all over. I'm going from grams of 1 to moles of 1. So I'm going from grams of oxygen to moles of oxygen. So 1 mole, grams is always weight, finding that on the periodic table. And I've noticed this on some of your guys' work that you're doing. You would just give me 16 here for 1 oxygen, but it is O2. So that is really 32. All right, now I've got to switch over to my moles of oxygen. Going from moles of 1, now I'm going to switch over to my water, my product. And I'm going to use the equation when I'm in a mole to mole. So for 1 mole of oxygen, I have 2 of water. So 24 divided by 32 times 2 gives me 1.5 moles of H2O. Now this is how much I will make. That is limiting me. So it says calculate the mass of water produced. The mass of water produced is going to be 1.5 moles. Now if it wants mass, I would need to go from here to here. I would say, okay, 1.5 moles of water, and I'm going to go moles of H2O, grams of H2O. Water weighs 18, so 1.5 times 18 is going to be, oh gosh, was that 27? I think. I'm going to check my math on that out on my calculator right here. It's going to be 27 grams. Now what I have seen kids do in the past is they will do this step right here. They'll do it for this one and for this one. And then they'll figure out which one was the lowest amount. And then they'll say, okay, well that's got to be it, right? Because at 1.5 moles, my reaction stops. Because I am out of oxygen. Now, yes, I have hydrogen left, but I have no more oxygen to react, so I am only going to make the 27 grams. I know this is a lot of math. Okay, so normally what I would do, and I was going to do this, but true to form here, I have forgot my keys for the past 2 days at home, so I can't even get into my chemical closet to get the baking soda or the vinegar. But you guys know it's like a volcano. Surely you've done that before. If not, we can mess with it in glass if you guys want to do this and see the baking soda and the vinegar bubble up. So basically what you see, and it's what you should expect, is the more baking soda you add, the bigger reaction you're going to get, right? Now eventually maybe you would add so much to where, because this is going to be limiting. My baking soda is going to limit how much I can make. Now eventually I would add enough baking soda that all of a sudden my vinegar would limit me. And so no matter how much baking soda you added, you wouldn't get any more of a reaction because you would be using all your vinegar up. All right, but for what we would do in here, and like I said, if we're back next week, then we'll do it in class. You guys can weigh these out and we'll see what happens. But you should see like a bigger and bigger kind of, not explosion, a bigger and bigger amount of product formed each time. So the chemical equation for this is NaHCO3. That is baking soda. It's a strong base. Now vinegar is an acid and it's acetic acid. So it is CH3COOH. Now eventually you guys will figure out how to write this out when we get to our acid and base section. But we have an acid and then a base. So we're going to get some CO2, we're going to get some water, we're going to have some sodium by itself, and we're going to get some acetate by itself. And that's what you get. Now it's all balanced. They all have just a 1 in front of them. But anyway, if you're looking at this, how much product was made in each trial, it's looking at 50 grams versus 1.5 grams. And I'm telling you right now that the baking soda is our limiting. It's not making a lot. We don't have a lot of it. So if I look at this and I say, okay, I have 1.5 grams of NaHCO3. Remember, first step is going from grams of 1 to moles of 1. So grams to moles of this NaH. I'm not going to write it all out. It's the NaHCO3. And if you were to weigh all of this, or add up the weight, sodium, hydrogen, carbon, 3 oxygens, that is going to weigh 84 grams in 1 mole. Now here's the nice thing about the second step. Because I went from grams of 1 to moles of 1, I'm going to go from moles of 1 to moles of 2, and it's always something in your product. So I just picked one of these. It doesn't matter which one you pick, because they're all 1 mole. I'm going to go with CO2. So 1.5 divided by 84, that only makes 0.01 moles of CO2. So that's not a really big reaction. Now you could go through and do this for trial 2 and trial 3. You're doing the exact same thing. You're just, instead of 1.5, I now have 3.5 grams. 84 grams in 1 mole. So everything stays the same. This is NaH. Everything stays the same except this part. That's the only part I'm changing. I'm just putting more in. This is 0.04. So yeah, the reaction should be a little bit bigger, right? A little bit. And then if you look at trial 3, I'm going to write it off to the side here. It's 5.5. 84 grams over 1 mole, and then we do our mole to mole, which is still just 1 to 1. And this is 0.07. So yes, my reaction's a little bit larger. All right, so this is limiting me. If you were to go up here and plug in 50 grams of vinegar, CH3COOH, and try to figure out how much CO2 you made, this is still just a 1 to 1 because all your products, everything up here is a 1. So the second step's always going to be a 1 to 1 on this one. If you were to add all of that up, gosh, let me see here. We've got carbon is 12, 12, 12, so it's 24, 27, 28, plus 32. Like I said, guys, my calculator is not here at the moment. So 0, 1, 60. So if you took 50 divided by 60, let me see, 50 divided by 60, it's going to be about 0.8. All right, so that's a lot more. It's going to take a while. Like, these guys are limiting you. You make 0.07 grams and the reaction stops, and you have a lot of vinegar left over. So we should see that. Like, when you guys come back, we'll try to do this, and we should see that we have a lot of liquid still left when that reaction's all said and done. All right, so anyways, that is limiting reactants, just trying to figure out who is stopping the reaction and how much are you able to make. All right? Let me know if you have any questions or having any problems with this stuff. I know this can be a lot, especially with the math and the conversions. All right, see ya.